Pollution and poor air quality silently shapes our daily lives, impacting our health, reducing life expectancy, and taking a toll on the environment that sustains us. Air and river pollution in South Asia, particularly in India, possess severe challenges with far reaching health, environmental, and economic impacts. Industrial emissions, vehicle exhaust, and agriculture practices contributes to the poor air quality, causing respiratory issues, heart diseases, and even shortened life expectancy for millions. Meanwhile, rivers, especially the Ganges and the Yamuna, suffer from heavy contamination due to the untreated sewage, industrial waste, and agriculture runoff. This not only endangers aquatic life but also compromises the water resources vital for drinking, farming, and sanitation. The economic burden of healthcare costs and lost productivity due to pollution related illness is immense, affecting vulnerable communities most severely. Addressing these crises demands urgent action to improve. Sustainable solutions are essential to address pollution challenges, moving beyond short term fixes and political cycles. Real challenges demand committed action for the long term health of our communities and environment. So, what is air quality? Air quality refers to how clean or polluted the air around us is. Good air quality means the air is fresh and safe to breathe, with low levels of harmful particles or gases. Poor air quality, on the other hand, has higher levels of pollutants like smoke, dust, chemicals, or vehicle exhaust, which can be harmful to our health and the environment as well. Monitoring air quality helps us understand if the air is safe and what actions can we take to improve it. Here comes the question of how to measure it. Air quality is measured using the tool called an air quality index, that is an AQI. AQI combines the levels of several common pollutants like particulate matter, ground level ozone, carbon monoxide, sulfur dioxide, and nitrogen dioxide. Each pollutant is monitored by sensors which gives us a reading. These readings are converted into an AQI number on the scale of 0 to 500. Lower AQI number means the air is cleaner, while the higher means worse air quality. An air AQI of 0 to 50, for instance, is considered good, while 300 plus is hazardous. The air quality index serves as a measure of the air we breathe, tracking 5 main pollutants that impact the health and the environment. These include ground level ozone, which forms when pollutants react with the sunlight and can cause rapid respiratory issues, carbon monoxide, a colorless gas from the vehicles, and burning fuels that can harm heart and lung functions. Sulfur dioxide, mainly from industrial emissions, which can lead to respiratory problems and acid rain. Nitrogen dioxide from the traffic and power plants, contributing to smog and asthma risks. And airborne particles, tiny dust, smoke, and soot particles that penetrate the lungs and bloodstream. By monitoring these pollutants, AQI gives us a clear picture of air quality and its health implications. Airborne particles, also known as particulate matter, come from various sources like construction sites, vehicle exhaust, and wildfires. These particles can also form through chemical reactions in the atmosphere, where gases like sulfur dioxide and nitrogen dioxide react and create fine particles. This mix of tiny dust, smoke, and chemical particles can travel through the air, often reaching the lungs and bloodstream, possessing serious health risks when inhaled. Monitoring and managing these particles is crucial to protect air quality and public health. In India, major source of air pollution stem from several key activities. Stubble burning, a common agriculture practice involving burning leftover crop residues, releasing large amount of smoke and particulate matter into the air. Biomass burning for cooking, where wood, crop residues, and animal dungs are used as fuel, is another significant source, especially in rural areas, leading to indoor and outdoor air pollution. Coal burning for power generation and industrial processes emit pollutants like sulfur dioxide and particulate matter, adding to the air quality concerns. Vehicle emissions from a growing number of cars, trucks, and buses releases harmful gases such as nitrogen dioxide and carbon monoxide. Additionally, industrial pollution from factories, manufacturing plants releases various pollutants including sulfur compound and volatile organic compound. Together, these sources contribute to a high pollution burden in India, affecting health, visibility, and the environment. Poor air quality and air pollution in India have significant health and economic impacts. In 2019, air pollution was linked to 1.7 million deaths across the country. This escalating health crisis not only affects individuals but also places a heavy burden on the India's economy. Air pollution related health issues results in larger healthcare costs, lost productivity, and reduced workforce efficiency. The economic losses attributed to outdoor air pollution alone amount to 1.4% of India's GDP. When combined with indoor pollution effects, the overall cost reaches 8.5% of GDP. This strain on both human health and economic highlights the urgent need for comprehensive measures to reduce pollution and improve air quality for a healthier and more sustainable future. The 2019 National Clean Air Program in India aims to tackle air pollution, yet it faces challenges due to limited public awareness and weak enforcement of regulations. Despite efforts in unregulated pollution sources such as industrial emissions and constructions continue to worsen air quality, especially as rapid urban expansion adds to the strain. Additionally, practices like roadside waste burning release smoke and toxins into the atmosphere, further degrading air quality. Natural dust events, often exacerbated by deforestation and land degradation, contribute to particulate pollution, while indoor pollutants from cooking fuels or poor ventilation affects millions, particularly in rural households. Combined, these factors create a complex air quality crisis that requires strong policy enforcement and greater public engagement for effective improvement. To read more, check out the link in the bio.